It is said that an object is thrown at a velocity of 15 meter per second and at an angle of 60 degree. So this one, the red one, is that the path of that object, and the angle is 60 degree, the velocity is 15 meter per second there. So that one is 60 degree. And at the same time another object is thrown, the green one, from in the direction of the first object. So this one goes this way and this one goes that way. So this one is thrown at a velocity of 20 meter per second, the velocity, and the angle is 45 degree. I mean, just arbitrarily drawn 45 degree. So, and the objects are 30 meter apart when they were thrown, or from the throwing points are 30 meter apart. So the question is how far away they land, from when they land, how far away they are from each other. So the red one lands here and the green one lands here. So we need to find this distance. This is our question mark. We need to find this one. So we can do one by one. First we can do this one, the red one. So if I do it, we know that Vy is equal to Uy minus Gt. So I am trying to figure out when it reaches the maximum height. So that is when the velocity, vertical velocity, is 0. So that will be Uy, which is 15 sine 60 degree over G. G can be used as 10, so that's 10. So this is the half of the travel time. The full travel time will be 2 times 15 sine 60 degree over 10. So that's the T1, or whatever the first one, the red one over there. So that's travel time. So the range that it has, so that will be the time. So ux time times t. So ux is 15 cos 60 degree times 2 time t is 15 sine 60 degree over 10. So basically this one is 15 square and 2 sine 60 degree cos 60 degree, that is sine 120 degree, because 2 sine alpha cos alpha is sine 2 alpha. We can use that formula. So 2 sine 15 degree 2 sine 60 degree cos 60 degree is sine 2 times 60 degree, that's some sine 120 degree. So this is the range that the first one has. Similarly, the second one will have similar thing. It will have, the velocity is 20 there, so that will be 20 square, and sine 45 degree times 2 is 90 degree over 10. So this one, if we calculate this one, it will become 15 square, so that's 225 times 0.866 over 10. So that is approximately 19.48 meter. So 19.48 meter, that means the red one, this distance is 19.48. Similarly, this one, the second one, this one is 400 over 10, sine 90 degrees 1, so that's just 40 meter. So the green one, that means this whole distance, the green one, this whole distance is I don't know, 40 meter. So it's getting a bit clumsy, but hopefully yeah, so that's 40 meter. So we are interested in this distance. We know this and this. So what we can do, we can subtract 30 from the 40, then we will have this much. We will have, then I will draw actually with a different color. This much we will have. So 40 minus 30, because this part is 30, this violet part from here to here, that is 30, as this one is drawn here, and the full, this one to this one is 40. So if we subtract 40 minus 30, that will give us this much, and then we have to add the 19.48, to get our desired distance, because this much is what we need. So 19.48 is already there, which is the range of the first one, plus the subtracted 20, subtracted 10. So 40 minus 30 gives us this one, plus this one will be our desired value. So that will be just 40 minus 30 plus 19.48, which is 10, and then 29.48, or can be written as 29.5 meter. So the particles or objects will fall, when they will land, they will be 29.5 meter apart from each other.